Good morning, students of grade 8 of Kumudini Kunja School, Kalimati. We are going to discuss about density and relative density. Today, this is the last part of your lesson, pressure. Okay. Now, let's start from density. We have already discussed about density in our previous class. Okay. Density means it refers to how heavy an object is. Refers to how heavy an object is. So take an example of an iron and a piece of wood having same size. Okay, same size means what do you mean? Equal volume. A piece of iron and a piece of wood having equal volume or same size. If we take a piece of iron and wood having same size, then which one is heavier? Which one is heavier? Definitely iron is heavier, isn't it? Iron is heavier than wood. Okay, here the concept of this concept, which one is heavier, it is actually based on density. Okay, so density is basically defined as mass contained by an object. Okay, mass contained by an object, okay, per unit volume. So that means if we take 1 meter length, 1 meter breadth and 1 meter height of any object, okay, then its volume would be 1 meter cube. If you take 1 meter length, 1 meter breadth and 1 meter height of any object, then its volume would be 1 meter cube. Then what amount of matter is contained in an amount of matter content in this object? That means mass. Yes, mass content in this object is then known as density. Okay, what amount of matter is contained in unit volume or 1 meter cube volume of a particular object is known as density. So come to iron and wood. Once again, let's consider the example of iron and wood. If I take a piece of iron and a piece of wood, both having same dimension, 1 meter length, 1 meter breadth, 1 meter height. Okay, 1 meter length, 1 meter breadth, 1 meter height. Then volume in both cases, volume would be 1 meter cube. 1 meter cube. Now, in case of iron, if you measure mass of iron, in this case, it should be around, I guess, 8,600 kg. Okay, mass 8,600 kg. And in case of wood, it's around 800 kg. It depends on different types of wood. Okay, I'm just taking estimated value. So in this case, mass would be 800 kg. See, so here you can see iron contains 10 times as much mass as the wood when same volume is considered. Okay, when same volume is considered, iron contains 10 times as much mass as wood. Okay, so it shows us that iron is 10 times heavier than wood. Okay, iron has 10 times more particles compacted in the same volume. Okay, so its density would be, as we said, density is mass contained by an object per unit volume. That means mass per unit volume. Okay, divide mass by volume. 8,600 kg in 1 meter cube. So its density would be 8,600 kg slash meter cube. And here in this case also, density equals to m by v, 800 kg by 1 meter cube. So it would be 800 kg per meter cube. So I hope you understood the concept of density. Okay, density is defined as mass contained by an object per unit volume. Its mathematical relationship is density equals to mass upon volume. Okay, and its SI unit is kilogram per meter cube, kilogram slash meter cube. And density, the concept of density refers to how heavy an object is. Okay, density, concept of density refers to how heavy an object is. That means an object having more density is heavier than the object having less density. Okay, now let's go to comparative term or relative term, that is relative density. Relative means comparative, when compared to another object. Okay, like I say Ram can run very fast and Shyam can also run very fast, but who is faster? Who is faster? Okay, to know that, we must let Ram and Shyam run together, isn't it? We must hold a marathon between Ram and Shyam. Okay, if you let both Ram and Shyam run together, okay, Ram and Shyam, if both of them run together in the same pitch for the same length, then we can say who is faster, isn't it? But what if Ram and Shyam are not available at the same time? What if Ram and Shyam are not available at the same time? Then we can use a medium, which would be medium to compare, which would be available all the time, or which can be considered as a standard. Okay, let us suppose a rabbit is considered as standard. Yes, a rabbit. Let us just suppose. Okay, rabbit is considered as standard. Then the calculation shows that Ram is 2 times faster than rabbit, whereas Shyam is 3 times faster than rabbit. Then by using this data, by comparing these two data, we can say that Shyam is faster than Ram, isn't it? So to say that Shyam is faster than Ram, we do not need to hold a marathon between them. Okay, we simply can use their data against rabbit. Okay, so this is known as relative speed. Okay, got it? Relative speed means the speed of the person when compared to a standard reference. Speed of a person compared to standard reference is relative speed. So what is relative speed of Shyam? 3. What is relative speed of Ram? 2. Now the same concept can be used in case of density also. Now if I just simply give you two objects, let's say copper, again iron and gold. I need to know which one is heavier. I need to know which one is heavier. Okay. Then instead of comparing them to each other, we can simply compare their density with some standard object, okay, standard reference, and keep the value. And that standard reference would be water at 4 degrees Celsius, which is available anytime, everywhere. Okay, water at 4 degrees Celsius, and density of water at 4 degrees Celsius is 1000 kg slash meter cube. This is standard value. Okay, now let's say gold. Gold when compared to water, density of gold is 19.8 times more. Okay, density of gold is 19.8 times more, whereas density of iron is only 8.6 times more. That means gold is 19.8 times heavier than water and iron is 8.6 times heavier than water. So by using this simple data, we can easily say that gold is heavier than iron, and this calculation would come handier. Okay, so this data when compared to standard reference, it is called relative density. Okay, so relative density is the ratio of density of a substance to the density of water at 4 degree Celsius. That means RD is equals to density of substance by density of water at 4 degree Celsius. Okay, and relative density does not have any unit. Why? Because in both numerator and denominator we have same unit, isn't it? In numerator also as density we have kg per meter cube. In denominator also we have kg per meter cube, which cancel each other. So there is no unit of relative density. Okay. Now last concept is about floating and sinking. And under what condition does an object float, and under what condition does an object sink? We will just go through surface. Okay, you will study about it in detail in grade 10. Suppose you are given a liquid, okay, and you are given an object. When you place that object in liquid, how do you determine whether it floats or sink? What is the basis of it? You need to know the density of liquid, okay, density of liquid, and you need to know density of object. Okay. So basically, if density of object is more, let's say dO and say dL, okay, if density of object is more than density of liquid, then object sinks. Okay, if density of object is more than density of liquid, then object sinks. For example, water. Okay, in water, density of water is 1000 kg/meter cube, but density of iron, okay, you are taking iron, then density of iron is 8600 kg/meter cube. See, density of iron is more than density of water, isn't it? Water has 1000 but iron has 8600. The iron is 8.6 times heavier than water. In this case, what happens? Iron sinks in water. Okay, when density of object is more than density of liquid, in that case object sinks. And another case, when density of object is less than density of liquid, then object floats. Okay, once again take an example of water. Density of water is 1000 kg/meter cube, but density of wood is only 800 kg/meter cube. Okay, see, density of wood is less than density of water, isn't it? So that's why wood floats in water. Okay, iron sinks in water because density of iron is higher than density of water. Yes, but wood floats on water because density of wood is less than density of water. Okay, this much is the lesson. Now there are few numericals, okay, regarding density and relative density. These are very easy, yes, because the formulas are quite simple. Density, what is the formula of density for numerical? Okay, for numerical use these formulas. Formula of density is mass per unit volume, and formula of relative density is density of object by density of water at 4 degree Celsius. Okay, use these two formulas and you'll be able to solve all the numericals. Okay, now I'll be giving you some exercise. You can pause the screen or freeze the screen and copy the questions. I will send the screenshot, send a picture of the exercise in your messenger group as well. Okay, fill in the blanks, true, false, pause the screen and copy it. Answer the following question and differentiate between give reason, numerical problems. Okay, this much is for today. Thank you.